Section 6.4. Let's get after it right away here, all right? And it's rational exponents. All right, so now we're going to deal with some things like some negative exponents. Okay, we're going to deal with rational exponents. Rational exponents means our exponents will be fractions. Right? Some of us, sometimes when we see fractions, we get a little hesitant. Okay, but relax. Okay, rational or negative exponents, it's as easy as just a couple of tricks. Okay, and I'm going to show you what those are here in today's lesson. All right, here we go. We start out here with just simplifying some of these expressions. Okay, and so if I have a number, whoa, sorry class, I lost you guys there for a second, but here we go. Let's get back at it. We are on number 10. Okay, so if I have 36 to the 1/2, that's a rational exponent. And whenever I have a rational exponent, it means you can rewrite it as a radical. Okay, and the rule of rewriting it as a radical is the following. The number on the bottom is your ditch, believe it or not. That is our root. It's the number that goes in the ditch. So this is going to be a square root. And then the number on the top is called your power. And you can write it either right there, okay, or you could have wrote the problem like this. You could write that 1 over the whole thing. Doesn't matter how you do it. Okay, I think this ends up being more helpful in the long run, because here we're just going to do, what is the square root of 36, class? It is 6. What's 6 to the first, class? 6. Boom, problem's done. Okay, and the reason why I say it's a little easier there is I'm going to take us a step further here. Okay, and I'm going to write 8 to the 2/3, and make sure you guys put this in your notes. Okay, and there's two ways we could rewrite this, okay, in order to simplify this expression. Remember, the number on the bottom, that is your root, so that number goes in the ditch. The number on the top is your power. Remember, you could write it there, which would be 8 squared, or remember, it's really like that, or you could put it on the outside. And it's always helpful to put it on the outside. I'm going to tell you why. Because, please excuse my dear Aunt Sally tells me to do that first. What's the cube root of 8? You guys know what that is? Well, 8 is 2 times 2 times 2. So you've got 3 2's. So then that means it's just going to be 2. And then you do 2 squared, which is 4, right? And we should know that, because if we're in 6.4 now, we've been doing this simplifying of radicals in 6.1, 6.2, 6.3, and 6.4. Hopefully we're getting more and more efficient at it. All right, let's do one more of these bad boys before we get on. I'm going to do 11. That's 27 to the 1/3. Remember, that number on the bottom, that is your root. That goes in the ditch. And it'd be 27 to the first, or I'm going to always write it both ways as we get started here. Okay, so what's the cube root of 27? Well, 27 is tree, tree, and tree. So if you have 3 of them, right, it's going to be 3 to the first, which is 3. Dun-do! Not too bad to simplify those, right? Do they get a little bit tougher? They sure can. Let's do the toughest of the ones that I see here on this page. And that would in the next row, okay? And that would be 15. 7 to the 1/2 times 21 to the 1/2. Okay. Well, in these problems, it's always helpful to rewrite these as radical. Remember that 2 is the number that goes in the ditch. Be 7 to the first. Do we really have to write it as 7 to the first? No, because 7 to the first is just 7. Okay, and then what about this one? 2 in the ditch, 21. Okay, now we go back to what we learned in 6.1 to 6.3, right? Can I multiply these two guys? For sure. Could I add these two guys? No. I can multiply them because they're both square roots, so what do I get there? Now remember, when we multiply, we don't actually multiply. 7 times 21. Well, what's 21? 21 is 7 times 3. So that means there's 7, and that's 7 times 3, so it's 7 squared times 3. Well, I got 2 7s. Right? So what does that mean if I have 2 7s? That means a 7 comes outside and that 3 stays in the outside. Right? We always have an imaginary 2 in the ditch. Okay, so that's that guy totally simplified. What else can we do right here? Let's go ahead and we'll go straight to, let's go to 18. Okay, we have 3 to the 1/4 times 27 to the 1/4. Okay, so what was the rule? Well, let's rewrite these as radicals. So that would be the 4th root of 3 to the first. 3 to the first is just 3. Times the 4th root of 27 to the first, which is just 27. Okay, that's why I'm not writing those parentheses. Okay, 27. Well, 27 is tree, tree, and tree. Why? I know that because it's 9 times 3. All right, so let's bring this all together. Actually, I skipped a step. Should do that, right? Because we can multiply it. And then, oh my gosh, we have 3 3s there. I have 1 3 there, right? That's 1, 2, that's 4. So then you get 3 to the 4th. 4 divided by 4 is 1. So I get 3 to the 1st, which is 3. Okay, hopefully you understood that. Some students sometimes can really struggle with the beginning of this rational exponent guy. All right, next. All right, these are simply, let's just rewrite these. And I already did this with you guys. All right, let's go with 21. How do I rewrite x to the 2/7? You're going to have some questions on our next quiz test that are actually this. Okay, 7 is the root. So it goes in the ditch. X squared, you can write it like this. Or remember, if I'm dealing with real numbers, I'm going to always tell you that it's more helpful to write it this way. Both are 100% acceptable. I couldn't even tell you, okay, on the SAT, which way they would write it. They could actually write it like either or. All right, let's see what else could be trouble. Ooh, let's do 24. That's t to the negative 3/4. Well, what's new about this bad boy? Well, Mr. T has got a negative exponent. Well, if it's got a negative exponent, we always first rewrite it as 1 over, as the reciprocal. And that turns it to a positive exponent. Okay? And then it says to write it in radical form. Well, how do I write this in radical form? So it'd be 1 over 4 goes in the ditch, right? And then remember, I said it could be t to the 3rd, and you don't ever have to write both of them out. Okay? All right, that's it. What else do we got here? Well, 23 is the same. These guys are a little bit different. We're not really going to see ones like this. You just need to know 1.5, and you can math rack it. Okay, you put 1.5 in your calculator and you math rack it, you get 3 over 2. Okay, so what do we do in this situation? Well, let's just rewrite it. 2 is the root, goes in your ditch, and you got x to the 3rd. Okay, and then you kind of need to simplify this. Well, it just says radical form, so you would be done. Okay, but remember, could you do 3 divided by 2? Eachy. Could you do 2 divided by 2? You could. So it'd actually be x square root x if I simplified. But in this particular example, they just wanted radical form, so you would be donezo once it is in radical form. Okay, so that's page 3. Let's go to page 4. All right, it says write each expression in exponential form. So all we're doing now is we're going backwards. Okay, we're going to go backwards. Let's do one that really will make sense right here. Let's do that, boy. Let's go backwards. Okay, so I'm going to write it as C, and when I say backwards is I'm going to rewrite it with rational exponents. And remember, what number goes on the bottom, what goes on the top? Well, the number on the bottom is the number in the ditch. So that'd be a 4. The number on the top is the power, and that'd be a 2. Boom, done. Okay, could you reduce? For sure you could reduce. That'd be 1/2, right? Okay, what else do we have? There's some of these that are different. So let's look at 28, 29, and 30 because they're all kind of different. Okay, 28 says the square root of 7x to the 3rd. Now, you know what's interesting here is that 3 is only on the x. That 3 is not on the 7. So we always want to group what's underneath the radical together. So this is together. Okay, so what exponent goes on this? 1, right? Because there's none there. There's none there. There's always an imaginary 1, except there, that's be a 2. So how do I rewrite this guy? Well, it's going to be 7x to the 3rd. You keep that parentheses. What number is in the ditch? It's a 2. What number is the power? It's a 1. So that is actually the answer. A lot of students would get that wrong because they would put a 3 up as the power, but it's not, because it's what's underneath the radical. All right, let's look at 29 because hopefully this will help you to understand what's going on a little bit better. Oh, now that 3 is on the outside. So that now it would be a 2 on the bottom because that's in the ditch, and a 3 up there because that's my power. Does that kind of make sense? And then remember going to 30, and that's why they do a good job at 28, 29, 30, so you truly understand what's going on. They write it like this. And remember, I said there were always 2 ways to write this guy. All right, that's the same thing as 29, as if you brought it on the inside. The important thing to know is in both of these, the power is 3. So it's a 3 as your power and a 2 as your ditch, right? As your root. Okay, and that's all it is for those. One looks like it's kind of tough, maybe 34. You have 5xy. What is the root? It's 3 because it's in the ditch. What's the power? It is 6. What's 6 divided by 3? It is 2. Okay, so that's it. And they just ask exponential form, so that actually would get you 100% credit. All right, here we go. Now, page 5. Okay, it says find each product or quotient. Okay, and it's important to understand what's going on here. I'm going to do the ones that are the most relevant for us in class, and guess what? None of them are. So let's go to page 6. Okay, these are the ones I need you guys to be really good at. We already did this one, 8 to the 2/3. Okay, but we're going to do it again to make sure we're okay. And they're asking you to simplify these without the use of a calculator, so they'll be on a non-calculator portion. Okay, so we draw a radical. What number goes in the ditch? It's 3. What number is our power? It is a 2. Remember, whenever you deal with these guys and they are not variables, I said it's always helpful to go this route because I have to simplify. What's the cube root of 8? Well, it is 2, right? Because 8 is 2, 2, and 2. And I have 3 of them, and 3 is in the ditch. And then you still have your power of 2. So it is 4. So we're going to get good at these in this section, okay? All right, let's go to the next guy. Ooh, this is a 64 to the 2/3 times 64 to the 2/3. What the heck do I do in this specific situation? Well, let's handle these guys separately and let's see what happens, huh? Okay, how would I rewrite that? Well, that would be the cube root of 64, and Mr. T said to put that 2 on the outside. And this guy is the same exact thing. Mr. T said to put the power on the outside. All right, so what is that guy? 64. Well, 64 is, believe it or not, is 8 times 8, which is a 2, 2, and a 2, a 2, 2, and a 2. So there are 6 2s. All right. There are 6 2s. All right, still got that 2 on the outside. And it's the same for this guy. Okay, and then what do we do? 6 divided by 3. Can I do 6 divided by 3? I sure can. 6 divided by 3 is 2. Equals. So that means it's 2, so that means it's going to be 2 squared, and I still have that square on the outside. That's going to be 2 squared, and I still have that square on the outside. Please excuse my daring means I do that parentheses first. What is 2 squared? 2 squared is 4. So it's going to be 4 squared times 4 squared. What's 4 squared? That's 16 times 16. What is 16 times 16? Class, that is, I might have to do a little longhand for that bad boy, right? 16 times 16. Let's go 6, 3, 9, 6, 1, 256. Okay? And that one was definitely a little bit tougher. Let's see what else looks like a little rough one. Oh, okay. We've got some negatives coming out here. So let's go ahead and we're going to do 49, 50, and 51, okay? Because we have negative 8 to the 2/3. Okay, what do we do there? We rewrite it like a radical. We got 3 there. We got a negative 8 on the inside, and then we're going to square it. Now, remember, how do we deal with negatives? Well, Mr. T said if it's negatives and odd right there, we just bring that guy on the outside. And then we break down 8. What's 8? That's a 2, 2, and a 2. So I got 3 2s, so it's just going to be 2, okay? And then squared, and what's negative 2 squared? It is 4. Okay, guys? All right, not too bad, right? We kind of already did that one. We just introduced the negative to it. All right, let's go. Let's try one more to make sure you're good. To the 6/5. The heck? 6/5? Okay, so then what? 5 is in the ditch. Negative 32, Mr. T said put that power on the outside. Okay, negative 32. Ooh, negative. So you can just bring that negative on the outside. 32, what the heck is 32? 8 times 4. 8 times 4, that's a 2 and a 2. 8 is 2, 2, and 2. Oh my gosh, I have 5 2s. Well, that works out beautifully because I have five 2s and there's a 5 out there. That means a 2 comes out. And then I do negative 2 to the 6th power, which, believe it or not, is 64. Right? And you'd be able to use your calculator, I think, in that type of a situation. Okay, now the only one that's different here in this little category would be 51. Why is that one a little bit different? Because it has a negative exponent. And remember, I said you deal with negative exponents first. How do we deal with negative exponents first? Well, we just rewrite it. Now it's got a positive exponent. Now how do we deal with that positive exponent? Well, we rewrite it like a radical. Right? 5 is in the ditch because it's on the bottom. And Mr. T said put that 4 on the outside. Okay, so 32. I think we just got done doing this. That's 1, 2, 3, 4, 5 2s. Well, if there's 5 2's and there's a 5 in the ditch, then that means it's just 1 over 2 to the 4th. Well, what's 2 to the 4th? It is 16. Done. So we got 1 page to go. Hopefully this stuff is okay. You may need to come in to help just to get confidence on this stuff. Woo! Here's our last page. Let's get it. Get it. These guys are a little bit different. Okay, this is what we call a power to a power. Power to a power. All right, and what does this look like? Let's see. 55. We got x to the 2/3 times power to a power. Whenever it's a power to a power, you multiply. Okay, I'm going to change to red because some of us are going to have to do side work. So you multiply the exponents when it's power to a power. So that gives me -6 over 3. -6 over 3 is -2. So if I do that, I just get x to the -2. Well, I can't have a negative exponent, so there's my answer for that problem. Not too bad, right? But a lot of us forget what to do. Sometimes we add, sometimes we subtract. But when it's a power to a power, you multiply. All right, let's do 56. That's a power to a power. So let's do side work. If it's side work, I do that, right? You could, some of you learned back in the day, you could spling, right? If you didn't learn that, it's okay. You multiply the 2 tops, you multiply the 2 bottoms, you still get -4. So I get x to the -4. You can't have a negative exponent, so we move that bad boy. Spling, done. Okay, now 57 is a little bit different. So make sure we, let's do, yes. Let's do 59. Okay, I won't keep you guys here all day, but I want to do some of these tougher guys. What do I do in this situation? Because there's a number and a variable there. We kind of say there's 2 things in that parentheses. Well, guess what? That 27 actually has an exponent on it. It is an imaginary ichiban. So guess what? There's no addition, there's no subtraction. That's a negative sign. So we actually share that to both of those. We multiply it to both. So that means I'm going to get -27 to the 3rd. Okay. And I'm also going to get x to the -3rd. Right? Because I have to share that 1/3 to both of those bad boys. And I think I made a little bit of a boo-boo right there. So let's go. It would be -27 to the 1/3, and it would be x to the -3. Okay, so now let's go ahead and deal with these things. And the reason why I said I made a little bit of a mistake, that negative is on the outside there, okay, because it wasn't in parentheses, and I almost put it in parentheses right there. So that means that negative is on the outside, so then it's going to be the cube root of 27 to the 1st. And then it's going to be x to the -3. Well, what's 27? 27 is tree, and tree, because it's 9 times 3, so I have 3 of them. So that gives me a -3, and then it would be x to the -3rd. Now, can I have a negative exponent? No, I can't. So that'd be that's -3 to the 1st. Very important. So -3 stays, but the x to the 3rd goes downstairs. We get rid of that negative exponent. Get gaze? All right. A lot of these are different. So let's what else could cause some trouble? Let's go. 61. Okay, x to the 1/2, y to the -2/3 times -6. Okay, that shares with both of those guys. And remember, if you've got to do side work, you show your side work. That's -6 over 2, which would be -3. Hopefully, you guys can do it a little bit quicker than that. If you can't, it's okay. Now, let's go to the y. It's -2/3 times -6. That'd be a 12 over 3, and that'd be 4. Okay, and so it'd be y to the 4th. And then, hey, if it's a positive exponent, it stays where it is. If it's got a negative exponent, see ya. All right, that's it. That's all you've got to do for those bad boys. Now, you might be saying, Mr. T, what do we do if it's division? Well, okay. If it's division, then what we do is the same thing as multiplication. We share it to everything that's on the inside. So let's go ahead. We'll do the 2 toughest ones, which would be 65 and 66. All right, so we have x to the 1/4 over y to the -3/4. Can we raise that to the 12th power? So remember, let's just share that to both of those. That's a power to a power. 1/4 times 12 is x to the 3rd. Once again, show the side work if you need to, okay? And if I share that to the bottom, that gives me y to the -9. Do either of those have a negative exponent. It sure does. That guy on the bottom has a negative exponent. So since it's on the bottom, it can go to the top with the opposite sign of an exponent. We always want positive exponents, okay? All right, last one. We have x to the negative 2/3 over y to the negative 1/3, and we raise that to the 15th power. Okay, so once again, you multiply. If you've got to show the side work, you know what? I'm going to show it one last time. Negative 2/3 times 15 over 1, that'd be negative 30 over 3, negative 10. Okay, so I get x to the negative 10. Let's do y. Y is negative 1/3 times 15 over 1, negative 15 over 3, negative 5. So it's y to, oh my gosh, they both have negative exponents. So let's flip-flop, right? It just flip-flops. So you get y to the 5th on the top, you get x to the 10th on the bottom, and we say it's donezo. That's it. All right, that is section 6.4. We are done with that bad boy. Some of these radicals and fractions and negative exponents can be tough. If they are, let me see you in class. Aloha.